Hi, today we're going to be learning about the properties of quadrilaterals. Quadrilaterals are shapes with four straight sides. The sum of the interior angles of a quadrilateral will always be 360 degrees. So in this quadrilateral over here, angle A plus angle B plus angle C plus angle D will equal 360 degrees, and our reason that we can give for that is sum of angles in quad ABCD. Now we're going to go on to an activity where you're going to investigate the different properties of the different kinds of quadrilaterals. If you have the worksheets that go with this lesson, you can just use the shapes that are provided for you. However, if you don't, you can quickly take a screenshot and print it out and you can work on these shapes. In this activity, you need to mark the parallel lines, the right angles, the equal angles, and the equal lengths in each of the diagrams that we're going to go through. You can use your ruler and protractor for measuring where necessary. I'm going to give you 30 seconds to do this for this diagram of a parallelogram over here. Okay, so let's go through all the properties that you should have marked. If you missed anything, make sure that you mark it now. So you should have marked that the opposite sides over here are parallel and these opposite sides are parallel as well. You should also have marked that these opposite sides are equal and that these opposite sides are equal, but that they are different to each other. You should have marked that these opposite angles are equal to each other and that these opposite angles are equal to each other as well. So that's everything that you should have marked for the parallelogram. Now we're going to go on to the next one, which is a rectangle. I'm going to give you 30 seconds for this one as well. Okay, so let's go through everything you should have here. So first you should have opposite sides parallel here and opposite sides parallel here. You should also have opposite sides equal over there and opposite sides equal over there as well. And you should have that the angles are all 90 degrees like that. Okay, now we're going to go on to the next one, which is the rhombus. 30 seconds again. Okay, so for the rhombus, you should have got these opposite sides parallel and these opposite sides parallel as well. You should have got all four sides are equal like that, and opposite angles here are equal, and these opposite angles are equal as well. Right, now let's go on to the next one, which is the square. 30 seconds again. Okay, so for the square, you should have opposite sides parallel here and opposite sides parallel there. You should have all four sides equal, and you should have all four angles equal to 90 degrees. Right, then the next one is the kite. You have 30 seconds again. Okay, now the kite is very different to the other ones we've done so far. There are no parallel lines in the kite. You should have that these sides over here are equal and these sides are equal over here. And you should have that these opposite angles over here are equal, but these ones are not equal, so we're just leaving those ones. Okay, and then the last one is the trapezium. You have 30 seconds again. Okay, so for the trapezium, the only thing that you would have been able to mark off is that these opposite sides are parallel. There are no sides that are equal. We can't say anything about angles being equal or anything like that either. So for the trapezium, that's all you should have got. Right, now we're going to go and look at the diagonals of the different quadrilaterals. So now, once again, if you've got the worksheets that go with this lesson, you can just use the shapes that are provided for you, but otherwise you can take a screenshot quickly and you can print it out. In this activity, you're going to be focusing on the diagonals of each of the quadrilaterals, marking off the important information again, like the right angles, the equal angles, and equal lengths. I want you to focus on the bisection of the diagonals, so you need to determine whether the diagonals bisect each other. That means whether they divide each other into two equal parts, so if they cut each other in half, and mark equal lengths accordingly. You need to focus on the angles of intersection, so check the angle at which the diagonals intersect each other, if they are perpendicular or not, and check the angle bisection. So check whether the diagonals bisect the interior angles of the quadrilaterals and mark equal angles if bisection occurs. I'm going to give you 30 seconds to do this one for the parallelogram. Okay, so for this one, you should have found that the diagonals bisect one another, which means that this line is equal to that line, and this line is equal to that line. They do not cut at 90 degrees, and they do not bisect the angles of the quadrilateral. Okay, so now we're going to go on to the next one, which is the rectangle. I want you to do the same thing for the rectangle. You have 30 seconds again. Okay, so for the rectangle, you should have found that all four of these are equal because the two diagonals are equal in length and they bisect one another. They do not intersect at 90 degrees, so they're not perpendicular, and they do not bisect the angles of the rectangle. Okay, now we're going to go on to the next one, which is the rhombus. I'm going to give you 30 seconds again. Okay, so for the rhombus, you should have found that these two are equal and these two are also equal, so the diagonals both bisect each other. You should also have found that they are perpendicular to each other. You should also have found that the diagonals bisect the angles in the rhombus like that. Okay, now let's go on to the next one, which is the square. You have 30 seconds again. Okay, so for the square, you should have found that all 4 of these lines are equal because the diagonals are equal to each other and they bisect one another. You should also have found that they were perpendicular to each other, so they bisect each other at 90 degrees. And they also bisect all of the angles in the square. And because the square has right angles, when it bisects, it cuts it into 45 degrees. So each of these angles over here is 45 degrees. Right, then we're going to go on to the next one, which is the kite. Okay, you have 30 seconds again. Okay, so for the kite, you should have found that these 2 lines are equal, but this diagonal is not being bisected. So this diagonal bisects that diagonal, but not the other way around. And the 2 diagonals intersect at 90 degrees. They are perpendicular to each other. You should also have found that this diagonal bisects this angle, and it bisects this angle over here as well. But this diagonal does not bisect the angles. Right, then the last one is the trapezium. You have 30 seconds again. Okay, so the trapezium is different because the diagonals don't bisect each other, so there are no equal lengths we're going to fill in. They are not perpendicular, so we're not going to fill in a right angle, and they don't bisect any of the angles either. So for the trapezium, we're actually not going to fill in anything because there's nothing special we can say about the diagonals for a trapezium. Right, now we're going to go and put all of these properties together into a table. If you have the worksheets that go with this lesson, you can use the table that's provided. Otherwise, you can quickly take a screenshot and print this out to work in. Okay, so in this activity, you need to complete the table by putting a tick in each block if the property described is true for the quadrilateral. I'm going to give you 3 minutes to complete this table. Okay, so let's go through what you should have got. So first of all, we're going to look at the properties relating to parallel sides, or the length of the sides, or the angles in the quadrilateral. So first, looking at the parallelogram. The parallelogram has got two pairs of opposite sides that are parallel. In a parallelogram, there are two pairs of opposite sides that are equal. And in a parallelogram, there are two pairs of opposite angles that are equal as well. Now looking at the rectangle, there are two pairs of opposite sides parallel as well. There are two pairs of opposite sides equal, and all of the angles are 90 degrees, and there are two pairs of opposite angles equal as well, because the opposite angles are still equal with all of them 90 degrees. In a rhombus, we also have two pairs of opposite sides parallel. We have all four sides equal. Two pairs of opposite sides are equal. Two pairs of adjacent sides are equal. And there are two pairs of opposite angles equal. In a square, you've got two pairs of opposite sides parallel. You've got all sides equal, two pairs of opposite sides equal, and two pairs of adjacent sides equal. All of the angles are 90 degrees, and two pairs of opposite angles are equal. Then for a trapezium, only one pair of opposite sides is parallel. There are no sides that are equal, and there are no angles that are equal. Then for a kite, there are no parallel sides. Two pairs of adjacent sides are equal, and only one pair of opposite angles is equal. Right, so those are all the properties related to parallel sides, the lengths of the sides, and the interior angles of the quadrilaterals. Now let's have a look at the properties relating to the diagonals. So first, the parallelogram. In a parallelogram, the diagonals bisect each other. Both diagonals bisect each other. In a rectangle, the diagonals are equal and they bisect each other. In a rhombus, the diagonals are perpendicular and they bisect each other. And they also bisect the angles of the rhombus. In a square, the diagonals are perpendicular, and they are equal, and they bisect each other, and they both bisect the angles of the square. Then for a trapezium, there was nothing that we could say about the diagonals of the trapezium. And then for a kite, the diagonals are perpendicular to each other, and one diagonal bisects the other diagonal, and only one diagonal bisects the angles in the kite. Okay, so those are all the properties of the different quadrilaterals. Now we're going to go and look at the quadrilateral family. First of all, remember that a quadrilateral is any shape that has four straight sides, but there are lots of different kinds of quadrilaterals. So first of all, let's have a look at the kite. So the kite has got two pairs of adjacent sides that are equal, and it has no parallel sides. Then we've got on this side over here a trapezium which has one pair of parallel sides. If we add another pair of parallel sides, we get the parallelogram. Okay, so over here we've got our parallelogram which has two pairs of parallel sides. Then the parallelogram kind of has its own little family. You get a rectangle, which is a special kind of parallelogram. It still has two pairs of opposite sides that are parallel, but it has right angles. Okay. Then you also get another special kind of parallelogram, which is the rhombus, where you still have two pairs of opposite sides that are parallel, but the adjacent sides are also equal. So in fact, all of the sides in a rhombus are equal in length. Now, if you take the rectangle and the rhombus and you put those together, you kind of squash them together and you put their properties together, you end up with a square, where the square has the property of a rectangle that the angles are 90 degrees, and it also has the property of a rhombus that the adjacent sides are equal. And so you have a square, which is a very special kind of parallelogram because it has opposite sides that are parallel, but it also has 90-degree angles like a rectangle, and it has adjacent sides equal like a rhombus. Remember, all of these are parallelograms. but these are special kinds of parallelograms. A rectangle is a parallelogram with right angles, a rhombus is a parallelogram with adjacent sides equal, and a square is a parallelogram with right angles, which makes it a rectangle, and adjacent sides equal, which makes the rhombus. But when you put those together, you get the square. Now we're going to go on to the conditions for proving that a quadrilateral is a parallelogram. There are 5 different methods that you can use to prove that a quadrilateral is a parallelogram. The first one is to prove that both pairs of opposite sides are parallel. And if you do it that way, then your reason will be 2 pairs of opposite sides parallel. The second method is to prove that you have 2 pairs of opposite sides equal. The third method is to prove that you have 2 pairs of opposite angles equal. And then the fourth method over here is to prove that you have 1 pair of opposite sides that is both parallel and equal. So all of those are working with the opposite sides or angles in your quadrilateral. If you know about the diagonals, you can also prove that it is a parallelogram if you can prove that the diagonals bisect each other. Both diagonals have to bisect each other. Next, the conditions for proving that a quadrilateral is a rectangle. A quadrilateral is a rectangle if it is a parallelogram that has one 90-degree angle. So first you have to prove that the quad is a parallelogram. If you can prove that it's a parallelogram using any of the 5 methods that I showed you on the previous screen, then you can prove that it's a rectangle if you also know that it has a right angle. If it's a parallelogram and has one right angle, then you know that it's a rectangle. Another method for proving that a quadrilateral is a rectangle is to prove that the diagonals are equal to each other and that they bisect each other. So your reason here will be diagonals are equal and bisect. Okay, next, the conditions for identifying a rhombus. Once again, remember a rhombus is a special kind of parallelogram. So first you need to prove that it is a parallelogram, and then if you can prove that it also has adjacent sides equal, then you know that it is a rhombus. So you prove that it's a parallelogram with one of the methods that we have already talked about. Then you also need to know that the adjacent sides are equal, and then you will know that it's a rhombus. The other method for proving that a quadrilateral is a rhombus is if you have diagonals that bisect at 90 degrees. If you know that diagonals bisect each other and that they are perpendicular to each other, then you know that this is a rhombus. Next, the conditions for identifying a square. Now remember, a square is a special kind of parallelogram, but actually it's even more than that. It's a special kind of rectangle. So if you can prove that your quadrilateral is a parallelogram with a right angle, so it's a rectangle, and it also has adjacent sides equal, then you know that it is a square. But once again, there's another way of proving that a quadrilateral is a square if you know about the diagonals. If you know that the diagonals are equal to each other and that they bisect each other at 90 degrees, so they're perpendicular, then you can prove that it is a square as well. Right. Next, the conditions for proving that a quadrilateral is a kite. A kite has 2 pairs of adjacent sides that are equal. So as long as you can prove that 2 pairs of adjacent sides are equal, then you know that it's a kite. The other method is to work with the diagonals. If you can prove that one of the diagonals bisects the other diagonal and that the diagonals are perpendicular to each other, then you can prove that it is a kite as well. And then the last one is the trapezium. In order to prove that a quadrilateral is a trapezium, all you need to know is that there is 1 pair of opposite sides that are parallel to each other. Now we're going to go and practice identifying different quadrilaterals. In this activity, we need to identify the quadrilaterals with reasons. Okay, so you need to look at this shape that I've given you over here and think about all the reasons that we've learned and identify which quadrilateral this is based on the information that you have. Be careful, don't make assumptions based on what it looks like. You have to only go with the information that you are being given. Okay, I'm going to give you 30 seconds for this one. Okay, so you should have found that this quadrilateral is a rectangle. Be careful, it's not a square, or at least it could be a square, but we don't know enough to say that it's a square. Okay, based on what we can see, the information we've been given, it is a rectangle. And the reason we can say that is because the diagonals are equal to each other and they bisect each other. Okay, so diagonals are equal and bisect. Right, next one. You have 30 seconds for this one as well. Okay, so this one, you have to be careful again. It looks like a rectangle, but you can't make assumptions based on what it looks like. The only information that we have here is that there is one pair of opposite sides that are parallel. So as far as we know, this is a trapezium, and our reason is one pair of opposite sides parallel. The next one, question C, you have 30 seconds again. Okay, you should have found that this one is a kite because there are two pairs of adjacent sides equal. Right, the next one, question D, you have 30 seconds again. Okay, this one over here is a parallelogram. We know that because there are two pairs of opposite sides parallel to each other. Question E, you have 30 seconds. Okay, for this one, you should have found that this is a parallelogram. Be careful, it may look like a rhombus, but we don't have enough information to say that it's a rhombus. All we know is that the diagonals bisect each other, which means that it is a parallelogram. Right, next one, question F. You have 30 seconds again. Okay, now this one is a square. We know that because all of the angles are 90 degrees, which means that it's a rectangle, and it has adjacent sides equal, which makes it more specific, and it's a square. Okay, so it's a square, and our reason is all four angles are 90 degrees, and there is one pair of adjacent sides equal. Next one, question G. You have 30 seconds again. Okay, in G we have a rhombus. It's a rhombus because first of all we can prove that it's a parallelogram because the opposite sides are parallel. There are two pairs of opposite sides parallel, and we know that the adjacent sides are equal, so that makes it a rhombus. So it's a rhombus, and our reason is two pairs of opposite sides parallel and one pair of adjacent sides equal. Then our last one for today is question H. You have 30 seconds again. Okay, so you should have found for this one, first of all, you can prove that it is a parallelogram because you have one pair of opposite sides that are parallel and equal. And then also you have a right angle, which means that it is a rectangle. Be careful, it looks like a square, but we can't prove that it's a square because we don't have enough information. So we can say that it's a rectangle because there's one pair of opposite sides parallel and equal, and there is a 90-degree angle. And those are the properties of the quadrilaterals and how we use the properties to identify the quadrilaterals. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.